Have you ever heard someone say their computer has a bug? Or that a programmer is busy debugging some code? These terms are so common now that we rarely stop to think about where they came from. You might imagine a digital glitch, some invisible error in the lines of code. But what if I told you the very first computer bug was a real, actual insect? This is the story of how a tiny moth made a huge mark on the history of technology. To understand this story, we need to travel back in time to the 1940s. Forget the sleek laptops and smartphones we have today. The earliest computers were colossal machines, filling entire rooms. One of the most famous was the Harvard Mark II, a beast of a machine built with electromechanical relays. These weren't silent silicon chips. They were physical switches that clicked open and shut to perform calculations. Imagine thousands of tiny metal switches all working in concert, clicking and clacking away like a mechanical symphony. This was the sound of early computing. On a warm evening, September 9, 1947, a team of engineers, including the pioneering computer scientist Grace Hopper, were working with the Mark II. The machine was a marvel of its time, but it was also incredibly complex. Suddenly, the calculations stopped. The machine had failed. The team was baffled. They ran their diagnostics, checked the programming, and tried to figure out what could have possibly gone wrong. For a computer of this scale, a failure could be caused by any one of its thousands of moving parts. The engineers began a painstaking process of elimination, checking each component of the massive machine. It was a tedious task, like searching for a needle in a haystack. But they were determined. After hours of searching, one of the operators finally located the source of the problem. There, stuck between the contacts of relay number 70, in panel F, was a moth. The small insect had flown into the machine, attracted by the light and warmth, and had been squashed by the closing relay, preventing it from making a proper connection and halting the entire computer's operation. Grace Hopper, known for her sharp wit and meticulous record-keeping, saw the humor and significance in the moment. She carefully removed the insect with a pair of tweezers and taped it into the team's logbook. Next to the tiny moth, she wrote the now famous words, "First actual case of bug being found." This wasn't just a joke. It was a literal, historical record. The team had quite literally found a bug in the computer. From that day forward, the term bug became shorthand among the engineers for any unexplained glitch or problem in the hardware. When a machine wasn't working correctly, they would say they were debugging it, looking for the source of the trouble. While the term bug had been used in engineering before to describe a flaw, this specific, well-documented incident cemented its place in the vocabulary of the new and burgeoning field of computer science. Grace Hopper herself helped popularize the term. As she traveled and gave lectures about her work, she would often tell the story of the moth, showing the page from her logbook. The story was charming, memorable, and perfectly captured the frustrating, often unpredictable nature of working with complex machinery. It resonated with other programmers and engineers who were facing their own mysterious issues. As computers evolved from massive mechanical relays to vacuum tubes, then to transistors, and finally to the microprocessors we use today, the nature of the bugs changed. They were no longer physical insects, but flaws in logic, errors in code, or unexpected interactions between different software components. Kit. The name stuck. Today, a programmer might spend days hunting down a bug that's just a single misplaced semicolon in thousands of lines of code. The process of finding and fixing these problems is still universally called debugging. Think about it. Every time you hear about a software update that fixes some bugs, or a game patch that addresses glitches, you're hearing a direct linguistic echo of that night in 1947. That single moth, taped into a logbook, created a legacy that has outlived the very machine it stopped. The Harvard Mark II has long since been dismantled, but the term it helped create is used by billions of people around the world every single day. It's a powerful reminder that sometimes the biggest innovations and enduring ideas come not from grand planned discoveries, but from small, unexpected accidents. It shows us how human ingenuity can take a problem, even a bizarre one like a moth in a machine, and turn it into a story, a concept, and a fundamental part of our shared technological language. The history of technology is not just a story of successes. It's also a story of the mistakes, the glitches, and the literal bugs that we find and fix along the way. These moments don't just solve a problem. They shape how we think and talk about innovation for generations to come. So the next time your app crashes or your program freezes, you can picture that little moth, a tiny, accidental pioneer in the world of computing. You're not just dealing with an error. You're participating in a tradition that started over 75 years ago. A tradition of finding the bug, fixing it, and moving technology forward. Thanks so much for watching. If you found this story as fascinating as I do, please hit that like button and subscribe for more deep dives into the surprising history behind our everyday world. See you in the next one.